Okay, hello again. This is chapter 5. We are going to finish chapter 5 in this video. Okay, so let's get started. This is the sections that I'm going to talk about, these two, the last two sections. Inverses and also modeling using variation. All right. As usual, I'm going to get rid of my video and continue. So before I talk about it, I want to first of all remind you of inverses, how to find inverses. Let me get some area we can work with. So we know about inverses, how to find inverses. So all we have to do to find an inverse is to let f of x be y, right? And then switch x and y. And then solve for y. So we have to take a square root of both sides. So we get plus and minus. Square root of x equals to y minus 4. So y equals to, would bring the 4 to this side. It would be 4 plus and minus square root of x. Now the question is, what is f inverse? Well, it cannot be the plus and minus, 4 plus and minus, because that's not a function. So what we have to do is we have to decide whether we use the minus or we use the plus. That's the question. Now, to answer that question, we have to think about that in general, if we have a function that doesn't pass the horizontal line test, then that function is not one-to-one. So that means if we find the inverse of this function, the inverse will not be a function. Now, remember, most polynomials look like that, right? Most polynomials don't pass horizontal line test. So it's hard to find the inverse for polynomials. In fact, polynomials, think about it. If I give you something like this, it would be pretty hard to find the inverse of this, because what we have to do, we have to switch x and y. Now we have a fifth degree polynomial in terms of y, and then we have x on this side. It would be very hard to find the inverse of these functions. So some of them we can find the inverse, like this one. But even this one, if we graph this, you're going to see that even the one that we are given does not pass the horizontal line test, right? So if we graph this, what do we get? So let me graph it here. Here's the original graph. Now remember, this is x squared moved to the right 4 units. So 1, 2, 3, 4. So this graph looks like this, right? Obviously it doesn't pass horizontal line test. But notice here that the domain is what? The domain is restricted to 4 to infinity. That means this part of this is good. This part is no good. So we have to erase that. So the graph that we're looking at is this graph right here. Right? That's the graph of this in restricted domain. Now, what is the range of this? Well, the range is from 0 to what? From 0 to infinity, obviously, right? So the inverse function, whatever it is, we still have to decide which one of these. The domain of the inverse is going to be the range, and the range of the inverse is going to be what? the domain. So now here, the way we decide is to look at what this is. This is y value, right? And the y values come from the range, right? So the y values are in the range. So the range here is 4 to infinity. So if I pick, and the domain is 0 to infinity. So if I pick the minus, if I put, let's say, 1 in here, 4 minus the square root of 1 is 3, which is not in the range. So I need to pick the positive one. So f inverse is going to be 4 plus square root of x, which is basically taking the square root of x 4 units up. Square root of x is over here, right? So we just have to move it up, what? 4 units. 1, 2, 3, 4, something like that. So it's going to look like that. And this one also continues that way. So they actually meet in that place. And notice that they're what? They're reciprocal. They're symmetric with respect to what? Y equals to x. Now we could also graph this function and its inverse with the calculator. The trick to use is to, let me erase this. The trick is to use the function, let's say x minus 4 squared, right? So we're going to take this and divide it by parentheses the domain, which is x greater than or equal to 4, right? That's the domain. So we put the function here, but then divide it by parentheses x greater than or equal to. Where do we get greater than or equal to? From here, test. So we go get greater than or equal to, and then we put 4. So what happens is that calculator considers this to be a logical statement. So every time we have a number for x that is greater than or equal to 4, this value in the denominator would be 1 and doesn't change anything, so the calculator graphs it. But on this side of 4, when x is smaller than 4, this statement would be false, so the calculator replaces it with a 0. And since 0 in the denominator doesn't make sense, the calculator will not graph this part. So let's go see. Let's go to zoom 4 or zoom 6 actually, so we can get a better picture of it. So you see, only graphs that part. So this part is not graphed. We do the same for the inverse. So the inverse is that. We're going to put it in parentheses. 4 plus square root of x. And then we divide it by parentheses. Now the domain has to be greater than 0. Now we don't have to really divide it by anything, because this graph, the domain is automatically what we want, right? If you do it, doesn't change anything, so we are not gonna do it. We're just gonna graph it. There. See that? So it's symmetric with respect to y equals to x. Now this window is not square, so the scales on the x and the y are not, exactly the same. If you want that, you have to go to zoom square, and you see that geometrically it looks like it's symmetric, right? So the scales on the y and the x are exactly the same. So anything that is, let's say you have a circle here, it would look like a circle. If your zoom is not a square, then it might look like an oval. Okay, so that's the function and its inverse. So that's one. And let's do another one. Why don't we do number 17? It's a good one to do. So here's number 17. So let's do one of these. So I want to find the inverse again. How do we do it? Well, we are going to let f of x be y, right? And switch x and y. And then solve for y. So square both sides. Move the 4y to this side. And move the x to the other side. X squared. And then divide by 4. So we get 3/4, right? Minus 1/4 x squared, right? Now, this is the inverse, but we have to decide on what the domain of this is. We know what the domain of this is, right? Domain is, so let's look at that. So domain of this is when 3 minus 4x has to be greater than or equal to 0. So that means what? That means 4x has to be, just move the 4x to this side. So that means x has to be less than or equal to what? 3/4, right? So the domain of this function is from negative infinity to 3/4, including 3/4. And the range, of course, would be all positive numbers. And if you put 3/4 over here, you actually get what? You get 0. So the range of this is basically 0 to infinity, right? This radical cannot be negative, has to be positive, and we know it starts from 0. So from 0 to infinity. Now, this is our inverse, so that's our inverse, and it's 3/4 minus 1/4 x squared. Now, what is the domain of the inverse? Well, the domain of the inverse has to be the range, right? And the range of the inverse has to be the domain, right? Now, let's graph these with the calculator, see what they look like. We use the same trick. Now, for the radical, we don't have to really do anything with it. We just want to just put it in there. So let me erase that and put the square root of what? 3 minus 4x, right? But for the inverse, we want to divide it by what? X greater than or equal to 0. Because we want to graph this, but we want to graph it in this domain. So let me erase that. Now don't forget to put the function in the parentheses. Now 3/4 is just 0.75, so I just put 0.75 minus, instead of 1/4 I put 0.25 x squared, and then close parentheses, so that's my numerator, divided by, don't forget to put parentheses for the denominator as well, x greater than or equal to 0. X greater than or equal to, oops, the wrong place, greater than or equal to 0. And then close parentheses. Now when we go to zoom, let's go to zoom square. We get what? We get these two that are inverses and they're symmetric with respect to what? Y equals to x. Let's see if we can get a better picture in zoom 4. Yeah, so you see that? It doesn't come all the way because the domain, you remember, it starts from ends from what? Ends to 3/4, right? At 3/4 it ends. It doesn't come down because that's the calculator thing. Let me go to zoom 6. So that's another picture of it. But even better picture of this would be if you graph it with what? With a program like GeoGebra. What we do in GeoGebra, we're going to put y equals to, let's say, square root of 3 minus 4x, and a square root means you raise it to what power? 1/2, right? That's that. That's good. So we have no problem. That's graphed in the right place, right? And then the other one is, well, I can't see it anymore. So it's y equals to 0.75 minus 0.25 x squared, right? But the problem is that GeoGebra is graphing this whole thing. I don't want it. I want it to graph it from here. So I'm going to turn it off. Then you do this. You do if. If is a statement that GeoGebra uses. You see, it says if the condition is satisfied, comma, then graph this. So the way it works is this part, you just put the condition, which is what? Which is, what is the condition? That x has to be what? That x has to be greater than or equal to 0. Greater than or equal to 0 is right here. And then put 0. And then tab. Now what you put there is the name of this that GeoGebra gave it, G. So basically what we are saying is this. If x is greater than or equal to 0, then do this. And it did it. See that, the red one? So see, without the condition, it will look like that. So, and if you graph y equals to x, you see they're symmetric with respect to y equals to x. All right? So that is how we find the inverses of these things. So let's do maybe a few more. Let's do 24. Now, this graph, as we discussed before, you can divide it, and you see there's a transformation of 1 over x actually. But for now, we don't need that. We just have to find the inverse. So we put y equals to x plus 3 over what? X plus 7. And then switch x and y. Now, obviously, we're going to get y in two places, right? And you just cross multiply or multiply both sides by y plus 7. So x times y plus 7 equals to y plus 3. So xy plus 7x equals to y plus 3. Now move all the y's to one side. So I'm going to keep the xy here. Move this y to the left side, make it minus y. So we took care of that too. Then equal to, we keep the 3 here. Now we'll move the 7x to the other side, would be minus 7x, right? Now, I have to factor the y out of here. So y times x minus 1, right? If I take the y out of here, I get x. Take the y here, you get 1. And now y equals to 3 minus 7x over what? X minus 1, right? Now, is this function one-to-one? Well, let's talk about that over here. Oops. Get rid of that and talk about it over there. So we know if we divide x plus 3 by x plus 7, we get 1 x plus 7 and subtract, right? Change the sign, subtract. We talked about that before. So negative 7 plus 3 is negative 4. So we can say that this function right here is, so we can say that x plus 3 over x plus 7 equals to 1 plus negative 4 divided by what? X plus 7. Now, these are 1, 2, 3 transformations of 1 over x. So you know 1 over x looks kind of like that, right? So if you move it around, it still keeps the fact that is what? That is 1 to 1, because there is no horizontal line that you get two intersections, right? There's always one intersection or none, right? So this thing is 1 to 1, right? So this function is 1 to 1. That means we don't have to restrict the domain, right? So that is the inverse. Now, obviously, the domain of this has restriction, natural restriction. We don't put restriction on it. It's just cannot be negative 7. And the inverse, of course, if you put negative 7, you can't have negative 7 for the function, right? Then you can have negative 7 in the range of this, right? So let's look at the graphs of these two. So we want to graph these two, and I want to graph them with. So the inverse is actually right here. So this is the inverse. Let me write it down. So here we go. So I'm going to graph, first I'm going to graph the inverse. Y equals to 3 minus 7x divided by x minus 1. 3 minus, yes. Okay, and the function is y equals to, again, we got one of these, and then we have to divide by another parentheses. The first parentheses is x plus 3, and the other one is x plus 7. There. Now, let me get this over here so we can get a better picture of it. So notice that this, if I put y equals x here, y equals to x in the middle, the red one and the green one are inverses, because we can tell, for example, this is the red one, right? So the reflection of this with respect to that line is that red one. This green one and that red one are actually what? Are actually, oops, I wanted to do that. So I need to, we got the inverse already, so I want to get rid of this. I want to talk about the shape right here. So this part right here has reflection right there, right? And this green one right here has this reflection, right? So green one is the inverse, and the red one is the function. And as you see, there are what? They are symmetric with respect to y equals to x. All right. So that was number 24. So let's do one more. So for the following, find the inverse of the function and graph both in the same graph the function and its inverse. Well, we talked about these already, so that's another one of those, so we can quickly do it, right? Now we know how to do these. So all we have to do is let it be y. Remember, the domain of this is what? The domain is 0 to infinity, right? And we know what this looks like, right? That's just x squared moved up what? 2 units. So the range is what? The range is from 2 to infinity. Now, we don't know what the inverse is. We haven't found it yet, but we know for sure that the domain and range are going to be what? The domain is going to be the range, and the range is going to be the domain, right? That's for the inverse. Okay, now what is the inverse? We can find it here. So switch x and y, then solve for y, right? It would be plus and minus the square root of x minus 2. But which one of these, which one, do we plus or minus? Well, look at the range. The range has to be positive, right? We can't have negative here. So the inverse is positive square root of what? X minus 2. Now, if you graph this, this looks like what? Again, we said you go to 2, right? And then since this domain is 0 to infinity, you have to graph it like this. Now, square root of x minus 2 is the square root of x moved to the right 2 units, right? So that's 1, 2. And that's the square root of what? X minus 2. This is x squared plus 2, but in the domain 0 to infinity. And obviously there what? There are symmetric with respect to what? Y equals to x. All right, I think we did enough of this section. So let's close this, and now we want to talk about modeling using variation. Now, what is that? Well, when two, so let's just start doing some problems. Let's do this one. Okay. Now, when two variables are related, that relationship is expressed with an equation in mathematics. For example, in physics, you might see something like this. Y is somehow related to X, right? This symbol means a relationship between X and Y. Now, if Y and X, both of them are in the numerator, there's no denominator, then we say this is the direct variation. Direct variation. Y varies directly as X. So now instead of using this symbol, we use equal sign and we put a constant here. So we know that Y varies directly as X, but this constant gives us the value that make him equal. This is the factor that makes them equal. So for example, if y equals to 2 times x, that means whenever you have x, if you multiply by 2, you get y, right? So for example, number of hours that you work is directly, varies directly as the number of, how much money you make varies directly as the number of hours that you work. But what's that constant? That's how much you get paid. Let's say you get, $20 per hour, right? So $20 per hour. So that's the relationship between how much money you make and number of hours that you work. That's a direct relationship. All right, so that's what we want to talk about here. So in number 4, it says y varies directly as x, And when x is 6, y is 12. So when x is 6, y is 12. That means k equals to 12 over 6, so k equals to 2. So the relationship is given by this equation between x and y in this problem. All right, so let's do one more. Let's do number 10. Now here we are told that y varies inversely as x. Now what does that mean? When two variables vary inversely, that means one of them is in the numerator, the other one is in the denominator. That's inverse relationship. So y varies inversely as x means this, but there is a constant here. And that constant you can put it in the numerator or you can put it here, it doesn't matter. But that's the idea. So here we say, they say y varies inversely as x when x is 4, y is 2. So y is 2 when x is 4. So basically 1/4 k equals to 2, so k equals to, multiply both sides by 4, you get 8. So the connection between the two is 8 times 1 over x. Or you could just write it as what? 8 over x. Okay? Now let's do another one. Let's do number 14. Now here we are told that x is, y varies inversely as the square root of x. So y varies inversely not as x, but as square root of x. So we got that. And when x is 25, y is 3. So when x is 25, y is 3. So that means 1/5 k equals to 3. So k equals to 5 times 3 is 15. So that means the relationship is, well, we can put this on the top right here. So we can put 15 over square root of x, right? All right, let's do a few more. What about 16? Well, in 16 we are told y varies jointly with x and z. What does that mean? That means y varies jointly with x and z at the same time. So y equals to some k times x times z. Put them closer. Now we are told that when x is 2 and z is 3, so when x is 2 and z is 3, y is 36. So that is 6k equals to 36. So k equals to 6. So this relationship is given by 6xz. Right? That's the idea. All right. Let's do a few more. What about let's do number 18. So again, here y varies jointly as the square of x and the square of z. So here's y. So it varies jointly as the square of x and the square of z, not y. Square of z. There. So that means there is a k here multiplied by that. Now we are told that when x is 3, z is 4, y is 72. So that is 9 times 16, which is 144. K equals to 72. So k equals to 72 over 144, right? Which is what? Which is 1/2, right? So k is 1/2. So that means y equals to 1/2 x squared z squared. Okay, that's the idea of varying jointly. Let's do a few more. 23. So here in this example, y varies jointly as x and z, and inversely as the square root of. So y varies jointly as x and z, and at the same time as the square root of w, and at the same time inversely as the square root of w and square of t. So inversely as the square root of w means that, right? And the square root and the square of t. So let me erase that. And at the same time 1 over square of t, right? So y varies jointly as x and z, inversely as the square root of w and the square of t. So you see all of that. So y equals to some constant times all that. Well, we can put all of these under one fraction. So we can think of it as k times what? xz in the numerator. And we can put the t squared first so you don't confuse it. Put it inside the radical, right? So that's t squared. Okay, so that's the idea. Now when x is 3, let's put it over here. So when x is 3, z is 1, w is 25, w is 25, t is 2, y is 6, right? We put all those numbers in there and we find k. So that is 3, right? And put the k here too, because 3 times k goes in the numerator. And that's 4 times 5 is 20. So 3k equals to 120, right? So k is 120 divided by 3, which is 40. So that's the formula for this, right? So the formula is going to be y equals to 40 xz, and then divided by t squared square root of w. All right, let's do an example of application of this. I'm going to go to, let's see, we need an application. What are the applications? Technology. Application. Here you go. 50. Let's go to 51. Very well. So it says that the distance s that an object falls varies directly with the square of time of the fall. And this is something that Galileo actually discovered, and many others. So basically they drop different objects from different heights, trying to figure out how long it takes them to fall certain distances, right? And then figure out the relationship between the distance something falls under the influence of gravity and the time that it takes it to fall. Of course, it didn't work because at the time it didn't have watch to to keep track of time. So eventually he used his pulse, but it didn't work because he got excited about the experiment. So what he did, basically, he used inclined planes like this, right? Like this, like that, and then rolled balls over what inclined plane and see how long it takes them to roll down. But anyway, the connection between the distance something falls and the time is given by this idea that the distance something falls is directly varies as what? As the square of time. And there is a constant here. And we can find this constant, and we have a formula for something falling in the presence of gravity only. So if an object falls 16 feet in 1 second, so that means if S6 is 16 in 1 second, well, that makes k equals to 16. So the formula is 16t squared. Now, how long for it to fall 144? Well, we put 144 for S and find what t is. So t squared is 144 divided by 16, and 144 divided by 16 is what t is, right? And so what's 144 divided by 16 and then take square root? Well, let's see. Let's get out of here. So 144 divided by 16 is 9, and then take square root. So that's a 9. So t is plus and minus 3. Obviously, the negative doesn't make sense here, so we use the positive. So the answer is it takes 3 seconds. Okay, so we are going to end this video here, and that is the end of chapter 5. Next video will be on chapter 6. So take care of yourself and others. I see you in the next video.